Hi, in this lecture, I'm going to talk about hash maps. Now, this is not a conceptual thing. A hash map is just a class in a java.util package. So, in this lecture, I'm going to show you how to use a particular class in the Java library, which is very useful. All right, this is not a language feature; it's a library class. So, I'll introduce the hash map as a useful lookup table. This is an important concept. Keys are unique in a hash map. So a hash map consists of it's a lookup table with key value pairs. Now every row in your table consists of a key followed by a value. So keys are unique. You can't have duplicate keys. And then I'll end up with some useful methods of hash map which you will use frequently. So let's look at one example. Before that, same thing, person class. A person class is simple. It has one attribute called name, a constructor which takes in the name, and a getter which returns the name. Now I'm going to use the person class in this example. I call this a hash map example. Of course, I've got to import java.util.star or import java.util.hashmap because the hash map class is in this package. So there's a main method here. So what do I do in main? I create 4 person objects. So P1, P2, P3, P4. They store the addresses of 4 person objects. Now with these names, of course. These are the names of the 4 person objects. Now, this is a statement on line 12. Okay. I'm declaring a hash map variable. So map is an object reference type variable. This is the part which creates the HashMap object. Now, some of you may be wondering what is this generic stuff. If you check the API documentation, HashMaps, okay, it is in the java.util package. It's a class. Name is HashMap with a capital M in the middle, K, V in angled brackets. So what does this mean? It means that when you create a HashMap object, it is a good idea to specify 2 types. Okay, the key type and the value type. The key type and the value type. Remember, a hash map is a lookup table. A lookup table means, a key is associated with a value. So you want to look up a table by passing in a key and the corresponding value comes back. So in this case, I am declaring map to be of type hash map. Key is a string, value is a person. It can be any kind of object. The key can be a person. Key can be an integer object. It does not matter. Same thing when I create a HashMap object, I specify very clearly that the key will be a string and the value will be a person object. Alright. Okay, this is the first method you will see. Put. Very important method of a hash map. This is the way you insert entries into the lookup table. Okay, and you pass in 2 things, the key followed by the value of the correct types. In this case, my key for this hash map is a string, so this must match string type. The value is a person object, so this must match the person object. Okay, I'm going to insert 1 entry into my lookup table. The key is JEN and the value is the address of the first person object. This statement inserts a second entry, a second row into my lookup table. The key is Jess. The value is the address of, Jessica Alba. A third entry, followed by the 4th entry. Okay, so this is how the put method is used. You use it to insert entries into the hash map. Be careful here. There's no guarantee that the entries will be that the sequence of the entries in your hash table is not guaranteed. So it does not mean that Jan will be in the first row, Jess will be in the second row, Emma will be in the third row, and Paris will be in the 4th row. There's no guarantee. The hash map does not guarantee sequence. It's not like an array list or an array whereby every element is strictly sequenced. There's an index to it. A hash map does not guarantee sequence, but what is guaranteed is that you have 4 entries, and these 4 entries, the key value pairs are there. Okay, so these 3 lines of code basically prompts the user for an ID. The ID will be Jan, Jess, Emma, or Paris. Okay, that's the key. And then I use a scanner object to retrieve the person ID from the keyboard. Okay, this is the second method which I'm going to introduce. Map.get is get. Now the get method is used to return the value corresponding to the key. So what do I pass in? I pass in the key and it returns the value, whatever the type is. So in this case, I'm passing in a string because the key for map in this example is a string, and this expression will return a person object, okay, which I store in this local variable called retrieve person. Now in the event that there is no such key in the hash table, in the hash map, get will return now. Is it documented? Yep. It returns the value to which the specified key is mapped on now if this map contains no mapping for key. So here I check if what is returned is null. I'll just print no person retrieved. Basically there's no entry in the hash map for that particular ID. Else I'll print out the name of the returned value, which is the person object. Let's just try this. HashMap example. Okay, so at this point in time, there are 4 entries in my HashMap. So I'll try to use the get method to retrieve Jen. Alright, so the retrieve value, which is a person object, which stores the name Jennifer Lawrence, is returned and printed out. Let's run it again. This time I'll try to retrieve Emma. Alright, now in this third run, I'm going to pass in something which is, not existent. I'll expect now to be returned, and when that happens, it will go into this if block and print out no person retrieved. Be careful when you use a hash map. It is possible for you to enter a null as a value, okay? Because you can pass in null as a value. When that happens, let me save this, compile it, okay, and run it. When this happens, okay, when I try to retrieve dumb, it says no person retrieved. Basically, this expression returns null. In other words, what I'm trying to say in this example is that this 5th entry in a hash map, in a lookup table, actually returns null as well. So be very careful. When the get method returns null, it may mean 2 things. It may mean that there's no such key in the lookup table, or it may mean that the corresponding value for that key is actually null. Okay? Now, if you really want to find out if that key is present, you can actually use a method called contains key. Alright, because if you call get, it is and you get null return, it is possible that the key actually exists on the hash table, on the hash map. So you can call contains key and pass in the key. In this example, it's a string, or it can be anything, and you get true or false. Now, what are the other useful methods? Okay, you have clear, you have is empty. Alright, clear basically removes all the entries in the hash map. Is empty will return true or false. depending on whether there are entries in a hash map. Now remove is interesting. It's the opposite of put, right? You can remove an entry in a hash map. Size will tell you the number of rows or the number of entries in the hash map, but remember the sequence is not guaranteed. Contains value. Okay, I showed contains key just now. Contains key. Alright, contains value works in a very similar way, except that now it checks if a particular value is present in the hash table. Now there are two more methods which can be useful. Values and key set. Now let's look at key set first. Key set. Here it is. Now key set takes in nothing and returns a set object. Okay, it returns a set object. Basically, key set returns a list of all the keys in the lookup table. There are certain circumstances you might want to have all the keys in the lookup table. Alright, now what is set? Now set is an interface. So if you are not familiar with interfaces, don't worry yet, let's treat it as a class for now. There are huge differences between an interface and a class, which you will cover in the lectures on inheritance. But does not matter if you are not sure what is an interface, just treat it as a class. So a set, it returns a set. And you can actually use the return set. Okay, let's see. Let me show an example. It's probably better if I show an example. Now let me comment this thing out. I'm not going to use the get method. Alright, I'm going to show you the key set. So set string keys equals to map dot key set. Okay, notice that when I declare the keys variable, I specify in angle brackets the type set angle bracket string. Okay, because that's how you're supposed to use set. There's an angle bracket e thing. Okay, it's a generics, which I'm not going to cover in detail here. Which basically means that keys will be a set of string objects. Okay, I can use a for each loop to print out all the keys. Okay, it's an enhanced for loop or the for each loop. Let me save this. Let me try to compile it and run it. Yep, all the keys are here. There are 5 keys, and of course each key has its corresponding value. Now notice, okay, look at the order in which the values are passed in. Notice that the sequence is not guaranteed, so do not rely on the sequence of the keys returned. Alright, it looks a bit random, right? You see, Dam was the last one entered, Paris second last entered, but Jan is the first one entered. So remember that hash maps do not rely on a sequence when you use key set or even value set. A value set is similar to set. Oh, I'm looking at the wrong documentation. Okay, not value set, values. So if you want a collection of values, just call the values method and it returns a collection, which is something like a set. It is also an interface. You can go through the collection and print out all the values if you want to. Okay. Now, when searching for a value in a hash map, please do not Please do not retrieve all the keys and go through the keys one by one, stuff like that. Please use the get method. Okay, that's the correct way to use a lookup table. Alright, if you want to look for an entry in lookup table, you don't retrieve all the keys and call get on each key and check the value whether it matches with your required value, right? You basically call the get method on the hash map, okay, and it automatically returns the correct corresponding value. Because I've seen students do that, it's ridiculous. It's a wrong way of using a hash map. Okay, so let's see what else. Oh, I forgot to mention to demonstrate that keys are unique. Now, what do I mean by keys are unique? Now, it simply means that if I try to pass in a second key with a same ID. So in this case, okay, I'm going to create a fifth person object. Let me create p5 equals to new person. All right, and I'm going to call the put method and pass in p5. Interesting thing is that jazz has already been used as a key. Jazz has already been used as a key. So what's going to happen? Let me save this and try and demonstrate. Okay, when I try to pull out Jess, I'm getting Nicole Kidman. Alright, which means that this statement actually replaces the entry on the hash map. Okay, replaces the previous entry on the hash map. You cannot have two rows on the hash map with identical keys. Alright, so how many keys are there here? 1, 2, 3, 4, 5, 6. But there are actually only 5 entries. There are only 5 entries. Let's check that out to prove it. Okay, I'm going to use a key set to retrieve all the keys. And let's check how many keys there are. See, there are 5 entries only. There are only 5 keys. Jan has been used twice. Not Jan, I mean Jazz has been used twice. So basically, what I'm trying to say is that you can't have duplicate keys in a hash map, which makes sense. You see, this is a lookup table. I think that's all I want to talk about for hash maps. Use it well. It's actually a very good class, a very good collection class.